It's easy to take sound for granted until you lose it due to a serious hearing disorder. Thankfully, this tiny hearing aid brings back the music. Loss of hearing causes a serious handicap, but happily it can be remedied thanks to hearing aids. But before fabricating the aid, the degree of hearing loss must be precisely measured with this apparatus called an audiometer. So they make a mold of the ear canal. To protect the eardrum, an autoblock is inserted. Next step is to pour in a silicone impression-making material. It solidifies and is then removed from the ear. This congealed mass, representing the ear canal, is then soaked in warm wax to obtain a positive imprint. Then the silicone container is filled. The silicone hardens in only 10 minutes. The hardened silicone block is removed, and the excess of the imprint is removed so that only the essential part is retained. The imprint must slip easily into the ear. It's now the molding stage for the hearing aid. Acrylic is poured into the mold before placing it into this ultraviolet oven. Without emitting any heat, this oven hardens the acrylic. Here is the raw prosthesis without its electronic components. This plan details the electric circuit of the amplifier. Holes are pierced for the volume control. These components are tiny. Here's the volume control, the miniature microphone that captures sounds, and the earphone which functions as a speaker. This tiny braided wire of 7 conductors is soldered to the amplifier and the other parts of the prosthesis with pewter. The hybrid circuit is inserted into a silicone casing, which assures it protection. Then the wires are soldered to the speaker, and they verify the proper functioning of the volume control. A hearing aid must be very discreet. That's why they cut the excess with a diamond disc. They also remove the roughness with fine sandpaper. The holes we see here are used to vent air from the earphone. This silicone tube is used to make the vent. Acrylic is poured onto the tube to form a tunnel. Ultraviolet light is used to harden the acrylic. Afterwards, the tube is removed. This hole is used to position the fastener, a small wire which allows for removing the hearing aid from the ear. Then the battery is installed. Only a few parts, such as the microphone, remain to be put in place. Then everything is delicately assembled into the interior of the prosthesis. The 2 parts of the hearing aid are then glued together. Ultraviolet hardens the glue. The plate used to position the prosthesis components is cut away with a drill. Then the hearing aid is manually polished to make it perfectly smooth and comfortable. The prosthesis is now completed. There remains one important step, verifying its electroacoustic characteristic. It's with this analyzer that they validate that the hearing aid conforms to the original prescription. These minute prostheses allow us to solve the main hearing problems. Microfabrication of a single unit requires a little more than 2 days of work. Remember putting together these simple 60-piece kids puzzles? Well, now imagine doing a 1,500-piece puzzle, 3D, with the pieces going up, down, and even sideways. Now there's a challenge. Flat puzzles are well known by everyone, but 3D puzzles present a different challenge. These three-dimensional puzzles are first conceived with computer software. Good blades are needed to cut puzzle pieces. Here are the blades for the master die, which will cut out printed sheets of different models. This rubber will be used to eject the die. The master cutting die is unique to each puzzle. It is the specific pattern used to make the puzzle. They measure it meticulously to obtain a perfect register. It's imperative that the die not move during the cutting, otherwise the pieces would be cut at the wrong points, so they very firmly secure it in place. The carbon of the die is positioned. It's somewhat like printing the master. Alignment is again verified, a highly important step which assures the quality of the final product. Finally, they install this large metallic plate, which is the cutting base. It will be on this surface that the master die will strike. Once measurements are finished, the drawer of the die is slid into place. This press cuts the pattern seen on the puzzle. Here's how it works. The sheets, or printed cardboards, go into the drawer one by one, where they are cut according to the master model. We clearly see the press making the cut in the puzzle sheet. The cut sheets pile up on one another, and at this checkpoint, they verify the precision of the cut. They make sure that every piece is correctly shaped. Now they go to the foam support of the puzzle. This guillotine is used to cut the polyethylene sheets onto which they will glue the cut images. Foam sheets are inserted into this laminator, heated to 232 degrees centigrade. The sheet with the design on it is glued onto the foam with a thermosetting adhesive. Now they glue the printed sheet onto the foam sheet. Once the adhesion is finished, the puzzles are stacked on one another, and they proceed to the unbuckling operation. By pulling, they remove the surplus cuttings. The same design is printed several times on a sheet, so they must separate each puzzle. This step is called the reduction of the models. Now the pieces have to be separated. This decorticator handles this task and sends the pieces down a chute. Packing cartons arrive already made up, and the puzzle pieces are placed in their boxes. No less than 15,000 puzzles are produced here each day. Since it began operations, the company has created more than 300 different puzzle models, from quite simple ones to much more complex designs. The largest of them contain a total of 3,146 pieces. And you need real patience for this one.